When we multiply something by itself, for instance, x plus 3 squared, you remember I was very adamant that under no circumstances is it x squared plus 3 squared. No, 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 no. It's a trinomial, 3 terms. Why? Because squaring means multiplying by itself. And when we have that, we would FOIL. We would get x squared plus 3x plus 3x plus 9. We combine the middle. There's 2 of them. We got x squared plus 6x plus 9. We had a formula. The formula was a plus or minus b squared would be a squared, and then plus or minus whatever we had, twice the first times the second, 2 times a times b, and then always plus, because even negative times negative is plus, square the second, b squared. And if we use the formula here, square the first, x squared, plus, because it's plus, 2 times the first times the second, plus square the second, gives us x squared plus 6x plus 9. I like to think of the middle as twice the first times the second. First times second here is 3x, double that, 6x. Why am I pointing out the multiplication formula again? What am I driving home about factoring? Factoring is the multiplication process in reverse. So if we have the direction factor x squared plus 6x plus 9, our answer is going to be x plus 3 squared. So let's see what the process of recognizing and getting this would look like. Now, x squared plus 6x plus 9, we can do this the other way. Numbers that multiply to positive 9 and add to positive 6. The numbers aren't just 9 and 1, 3 and 3. In fact, plus 3 plus 3. So x and x, because of the x squared, the numbers we found are plus 3 and plus 3. When we multiply something by itself, that means we're squaring. Problem is, not all of them will be that easy, is the nice way of putting it. So it'd be nice to have a process we can use when the square is a potential answer. And here's going to be our recognition. When we recognize that we have a trinomial and that the first term is a square and that the last term is a square, here we recognize that 9 is 3 squared. Here we recognize that x squared is x squared. What we would have to check is 2 times x times 3. If 2 times the first times the second does in fact give us the middle, and in this case, 2 times x is 2x times 3, that does give us 6x. When it checks, we can make our square. We can make our square. This sign here is the sign in the middle. And then we put our 2 things in, the x and the 3. So let's say we have 4x squared minus 36xy plus 81y squared. Well, we recognize that 4x squared is what we get when we square 2x. We recognize that 81y squared is what we get when we square 9y. So we want to check, is 2 times the first times the second, is 2 times 2x times 9y 36xy? 2 times 2x is 4x. 4x times 9y is 36xy. So yes, it checks. What does that mean? It means we are magically able to set up our square. Because it's a minus here, it is a minus here. We put in our 2 things, the 2x and the 9y. Why do we have to check for the middle? Well, because if we get anything but that middle term, it doesn't factor to this. Maybe it's prime, maybe there's something else to do. Let's do another. Nine y squared minus 12 yz plus 4z squared. I recognize here that I have 3y squared, and here I have 2z squared. 2 times 3y times 2z, that's 6y times 2z, that's 12yz. That is the middle term. I set up my square. Since it's a minus there, it's a minus in the middle. And my 2 things are 3y and 2z. Formula makes it quick and easy. And this is for factoring a perfect square trinomial, something in the form a squared plus or minus 2ab plus b squared. Let's say we didn't use the formula here. Well, then we have this same problem, 9y squared minus 12yz plus 4z squared. There's nothing that we can factor out everywhere. We have two variables, so I'm going to make it 9y squared minus 12y plus 4. I'm dropping the z's. We're going to come back to those later. We're going to factor here. AC, the multiplication goal. A times C, 9 times 4, that's positive 36. B, the addition goal, that's going to be negative 12. The numbers that multiply to positive 36 and add to negative 12 are negative 6 and negative 6. When it's the same number, that's a clue. It's going to be a perfect square trinomial probably. Since this was a 9y squared, airplane method says 9y, 9y. What we just found, we're putting in our numbers, minus 6, divide by what we can, 9 and 6, divide by 3. 9 and 6, divide by 3. This is 3y minus 2 times 3y minus 2. This would give us 3y minus 2 squared. But wait a minute, that's not our answer, because what did we do in the beginning? We took out the z's. I said we were going to come back to them at the end. And how do we account for it? Just put it with the other one. So instead of minus 2, it's a minus 2z. And that's our answer. So you can still do it if you don't know the formula. I want to mention that there is a method that I've completely skipped over. It's called the trial and error method, and it's quite the pain. Quite the pain indeed. It's basically what it sounds like. Trial and error is guess and check. Could take a long time. You could get lucky and it could be right away. If we had something to factor that was like, I don't know, 6, let me pick an actual one. If we had something like 14a squared plus 13a minus 12, and we didn't know anything. One thing we do know is that this is probably some binomial times some binomial. And to get a 14a squared, maybe it's a 14a times a 1a. Or maybe it's a 7a times a 2a. Or maybe it's a 2a times a 7a. Or maybe it's an a times a 14a. And then the last one for negative 12, maybe Maybe it's negative 6 times positive 2. Or maybe it's positive 12 times negative 1. Or maybe it's negative 4 times positive 3. We know that the first ones have to give us the first. We know the last ones have to give us the last. So you would write out every combination of these and those. There could be dozens, depending on how many factors these numbers have. And then you would FOIL each and every one of them until you find the ones where the outer and the inner work out to what you need. So just from that explanation, hopefully you understand why I'm skipping over that, why guess and check when we have these lovely methods that are guaranteed to get us our answers every time within the confines of a timed environment. Okay. Our last examples for the day will have to do with factoring by substitution. Now, substitution means taking something and replacing it with something else. So factoring by substitution is going to be a method of factoring whereby we take something and replace it with something else. In this case, we're going to replace it with something that's going to make the problem easier. Let's say we had 2x minus 7 squared minus 3 times 2x minus 7 minus 40. And we were told factor. Well, the long way to do this problem would be to first simplify this all the way down and then factor what's left. So this would be 2x minus 7 times itself. This would be distributed, so minus 6x plus 21 minus 40. When we do FOIL, this would be 4x squared minus 28x plus 49 minus 6x plus 21 minus 40. Oh boy, 4x squared negative 28 minus 6 would be negative 34x plus 49 plus 21, that's plus 60 plus 70. 70 minus 40 would be plus 30. So then we would have this 4x squared minus 34x plus 30, and we would go on to factor from there. Let me write this with some room to work. Factoring a trinomial. See what we can factor out. First, we can take out a 2. We're left with 2x squared minus 17x plus 15. To factor this piece, 2x squared minus 17x plus 15. AC, we would need numbers that multiply to positive 30, add to negative 17. These will be negative 15 and negative 2. Airplane method says a 2x squared gets us a 2x and a 2x. Plug in our minus 15, plug in our minus 2. Can't divide by anything here. Can divide by 2 here. We're left with 2x minus 15 times x minus 1. We're going to go ahead and this gets replaced with the 2x minus 15 and the x minus 1. This is the long way. This was not factoring by substitution. This is how we would have to do it using only the methods that we know right now. Next time we're together, I'm going to start by doing this same problem, except I'm going to show you how we can do it with substitution. We'll do more examples there, and then we'll move on into factoring binomials. Well, I said that we could do it with factoring by substitution, but I did it the long way. And that problem I did was 2x minus 7 squared minus 3 times 2x minus 7 minus 40. And the long way was expanding it all and getting a trinomial that I then went on and factored further. We got a final answer of 2 times 2x minus 15 times x minus 1, assuming this was the problem I did. If I did the one with 3x plus 1, we're going to see that. I can't remember. It's been a few days. We're going to do 2 of these anyway. If you do this the long way, you're going to get this as an answer. Here's what the short way is. We've got this thing squared minus 3 times this thing minus 40. And you can see this 2x minus 7 in both of these places. So factoring by substitution implies substitution, and that's exactly what we're going to have here. We're going to have some substitution. This, the 2x minus 7, is what we're going to substitute. We're going to make this substitution by saying, let u equal 2x minus 7. And why? Why do we do this? Well, u is the variable that we use for substitution. We could say any other letter. We just don't want it to be x, but u is the standard here. And why the 2x minus 7? Well, because think about what we would have if instead of 2x minus 7, we had u. It would be u squared minus 3 times u minus 40. And we know what to do here. We factor this, since it's a u squared, as u times u. the numbers that multiply to give us negative 40 and add to give us negative 3, those are going to be negative 8 and positive 5. Negative 8 times positive 5 is negative 40. Negative 8 plus 5 is negative 3. So negative 8 plus 5. Now you might be saying, ha, that's not the same answer. That's not even close to the same answer. Well, that's because we're not done yet. We just factored this thing with u. The problem has x's. Chill, hang on. So what am I going to do with this u minus 8 and u plus 5? Well, first of all, I'm going to give myself more room. And I'm going to write it up top. U is 2x minus 7. So now we're going to substitute back, bring it back to the x's. This would be 2x minus 7 minus 8 times 2x minus 7 plus 5 This simplifies to 2x minus 15. This simplifies to 2x minus 2. There isn't anything we can factor out here, but this one isn't completely factored. This can factor to bring out a 2 times x minus 1. And look, that means the whole answer is 2 times x minus 1 times that 2x minus 15. There's our answer. Same three factors. And we never had to multiply it out, distribute, combine like terms. We just did a substitution to get the answer. Let me do another with substitution. And like I said, maybe this is the one I did the long way. I can't remember. Let's take a look at 3x plus 1 squared plus 2 times 3x plus 1 minus 15. Well, here, our candidate for substitution, let u equal 3x plus 1. Because then we have u squared plus 2u minus 15. U and u to give us u squared. And the numbers that multiply to give us negative 15, add to give us positive 2. These would be plus 5 and minus 3. Multiply to give negative 15, add to give positive 2, plus 5, minus 3. But u is 3x plus 1, so this is 3x plus 1 plus 5. 3x plus 1 minus 3. (3x plus 6). 3x plus 1 minus 3, that's 3x minus 2. This is not completely factored, so we have to factor 3 out. 3 times x plus 2 times 3x minus 2. And that is our final answer. And if this is the one I did the long way, hey, look, it's the same answer. one of the things I want to point out here, I didn't just divide both sides by 3 like I did with the airplane method. This wasn't the airplane method of factoring. This is just factoring completely. Once here, this is a factored form. It's just not completely factored. We're done with the process of factoring right here. This is just bringing substitution back and factoring the rest of the way. In the airplane method, if we had this and then we would divide both by 3 because we can, that's a part of getting the factored form when we use that method. The reason that we're in a situation where this can happen, where we still have to factor a 3 out at the end, is because if we were to do this the long way, once we got the thing to factor, the first step would be factor out a GCF. And that 3 would get factored out then. Since we didn't have a GCF in our U forms, we end up having to take care of the GCF getting factored out all the way at the end. We wouldn't just divide it. That 3 has to stick around. It can't just go away. Make sense? Another thing I want to say is, when I filmed the last lecture, I did not know why it was called the airplane method. And thanks to a student who went above and beyond and looked it up and let me know, I now do know why it's called the airplane method. And I will share that with all of you at a future time, because we're not going to have time to go into it today. After all, it's not the name and why it is the name that's important. The importantness is the method. I want to look at one more substitution problem, and then we'll continue on with factoring binomials. Six y to the 6th minus 5y cubed minus 4. And now you might be looking at that and going, now wait a minute. I understood where we were getting that u equals whatever in the last one. It was obvious. Here, I don't see the same thing. I don't see, this doesn't look like the last substitution problem. Now, it may not look like it, but the end goal of all substitution problems are the same. The end goal is that it's just written with u squared and u instead of whatever's there. So you don't have to necessarily see what u is right away. You can go backwards. That's how I do it. I replace what's there with the form I want, with the u squared u. So instead of 6y to the 6th, I have 6u squared. Instead of minus 5y to the 3rd, I have minus 5u squared. And why? Well, because I know how to factor this, and I'm going to use the airplane method. But before we go ahead and continue, we do need to know what u is so we can make the substitution back at the end. And once it's in the form, you should be able to line it right up. This clearly means that u and y cubed are the same. Let u equal y cubed. Since we didn't set out to make that substitution to begin with, since we kind of discovered it, we want to check and make sure that u squared is actually u squared. So u squared should be y cubed squared. Y cubed squared, multiply the exponents, would be y to the 6th. U squared would be y to the 6th, and sure enough, U squared matches up with y to the 6th. That checks, so that's true. U is y cubed, and when we're done, we'll make that substitution back. But first, airplane method. This is a 6u squared, so we're going to write 6u and 6u. The numbers that multiply to AC, that multiply to 6 times -4, -24, and add to -5. That's going to be -8 and +3. Those multiply to -24. -8 plus 3 is -5. I'm going to put that in. -8 plus 3. We're in the airplane method. That's the only place where it's okay to just divide because we can. It's the only place where we're told, hey, divide if you can. Not factor out, divide. 6 and 3 both divide by 3. 6 and 8 both divide by 2. So this is 3u minus 4 times 2u plus 1. We're not done. These are u's. Our answer needs to be y cubed. So guess what? 3y cubed minus 4 times 2y cubed plus 1. Just substitute back. Instead of u's, now we're back to y cubes. And that's our answer. There's nothing more we can do to combine. There's nothing that can be factored out of either of the two factors. Now, when we were multiplying, just like in the last lecture, we looked at, hey, we can factor a perfect square trinomial and we get a plus b squared or a minus b squared. And that's the reverse of a special multiplication formula, because multiplication and factoring are reverses of each other. They're inverses. They go back and forth. If we factor, we get an answer. If we multiply that answer, we get the factored form, or the thing we factored. It just goes back and forth. Remember this one? A plus b times a minus b. We did that a few lectures ago, and we saw that this is a difference of squares. When we have a plus b times a minus b, we can do a squared minus b squared. Well, if we reverse it, we have a factoring formula. If we have a difference of squares, this factors to a plus b times a minus b. If we're subtracting two things squared, we set up conjugates, 1 plus, 1 minus, everything else the same. And then we plug in the first thing and the second thing. So the first thing and the second thing, first thing and the second thing. So let's say we had something simple. Let's start simple and just keep going. Make it harder and harder. If we had x squared minus 9, we know that this is a difference of two squares. X squared is what we get when we square x. 9 is what we get when we square 3. So the two things being squared are x and 3. To factor it, two binomials, conjugates, so 1 plus and 1 minus. X and 3 are the two things, so x and 3. X and 3. And that's that. What if it was a 16x squared minus 9? Well, 3 squared still gives us 9, but it's 4x that we square to get 16. Two binomials, conjugates, 1 plus, 1 minus. 4x and 3 are the two things, so 4x and 3. 4x and 3. King of the castle, king of the castle. That's all it is, the Borat method. If you didn't get the reference I just made, I'm not going to explain it, but if you got it, it might help you work your way through this. As Britney Spears might say, or might be forced to say, who really knows these days, gimme more. Here we go. Let's say we have 98 c squared d minus 50 d squared. Well, these don't look like squares to me. And actually, I wrote this wrong. This should be 50d cubed. And you know what? It still doesn't look like squares to me. But what is the first step of any factoring problem? GCF. Find a greatest common factor if it exists and factor it out. Here, 98 and 50 can both share a factor of 2. So we can take a 2 out. D and D cubed, we can take a D out. You can see how these lectures have been building. A few lectures ago, it was this that was the new. Factor out a GCF. That was the new material. Now that's old material. That's something we know how to do. What's left over? 49c squared minus 25d squared. Now you see why we're doing this example. This can be factored further using the difference of squares formula. We have two things being squared that are subtracted. What do we square to get 49c squared? 7c. What do we square to get 25d squared? 5d. So how does this factor? This wasn't factoring, this was just rewriting so that we can see square minus square. This is exactly the same as that. Well, you're glad I asked. It's a difference of squares. So we set up two binomials, conjugates, so 1 plus and 1 minus. Now I'll take the Borat voice. The two things are 7c and 5d. So 7c and 5d, 7c and 5d. Wah, wah, wee, wah. Look at us. Boom. I had a comment from a student earlier in the semester that a few lectures had gone on without me making any movie or TV references and that they were worried about me. Thank you so much. Hopefully I'm filling my quota now. 2d times 7c plus 5d times 7c minus 5D is our answer here. Go complication. I just can't stop now. Z to the fourth minus 81. Well, this is a difference of two squares. This is why I always set everything up, even the easy ones, in the square minus square form, because it helps. What are the two things being squared? 81 is obviously just 9. There's no variable with it. What do we square to get z to the fourth? Why were exponent rules in the same unit with factoring? This is why. Remember, power to a power multiplies, so this must be z squared. Z squared squared is z to the fourth. Difference of squares, so two binomials. Conjugates, so 1 plus and 1 minus. That's what conjugate means. Everything's the same except one's being added and one's subtracting. And then we put in the two things being squared. Z squared and 9. Z squared and 9. So we're done, right? Look at that answer very carefully and tell me, psychically, why we are not done. Oh my God. Who's moving my hand? Hopefully it was you psychically telling me, hey, z squared minus 9, difference of squares, we can keep factoring. We can't factor this anymore. A sum of squares is not factorable. So this is nothing. Z squared plus 9, if it was its own problem and it said factor this, the answer would be prime. Sum of squares, like x squared plus 25, that's always prime. But the answer here is not prime, because prime is only an answer you give if you cannot do even one single solitary factoring step. If you so much as take out a GCF, it's not prime. Okay, so here we can factor this one more, because z squared plus 9, that's z squared, or sorry, z squared minus 9. That's z squared minus 3 squared. So our final answer is actually going to be this z squared plus 9, and then the factoring of our other difference of squares. Two things, 1 plus, 1 minus, z and 3, z and 3. Boom. And that is the final answer. But we're going to move on to our next example. Y cubed minus 6y squared minus 4y plus 24. Well, it's been a while since we've started with a 4-term thing. How did we do this? Well, let's think back. 4 terms. Nothing can be factored out of all 4. There's no GCF. There's no like terms to combine. So it was factoring by grouping. Well, let's factor by grouping then. Surely, since we're talking about it now, there must be some difference of squares that's going to pop up at some point. But in a world where we don't know that, we start like we start anything. No GCF, 4 terms, factoring by grouping, group the first 2 terms. We can factor out a y squared, and we're left with y minus 6. Here, we can factor out a negative 4. We're again left with y negative times negative 6 is positive 24. Factor out the common y minus 6. We're left with y squared minus 4. That's why we're doing this. So if we continue to factor, y squared minus 4 would be y plus 2 times y minus 2, because it's y squared minus 2 squared. The two things are y and 2, y and 2. So that's the answer here. One more, and then we'll move into the very last factoring topic. Let's say we have x squared minus y squared minus 6y minus 9. I'll give you a second to get your wrong idea out of the system. And while you're doing that, I'm going to move this down just a little bit so I can get it out of the light. If you're thinking, hey, x squared minus y squared, x squared minus y squared, that's x plus y times x minus y. Wrong. Because it isn't just x squared minus y squared. There's other terms on here, so it unfortunately doesn't work that way. But what we do see is that this is an x squared, and this is a minus. So what exactly happens if we factor that minus out so that it's minus the rest of it? Is it possible that what we're left with is a square? Let's find out. If we factor out this minus sign, we have y squared Ooh, my phone battery is dying. Y squared plus 7y. Yeah, that's my phone up here doing all this. Plus 9. Double check we did that right. Minus y squared minus 6y minus 9. Yeah. Because we would check factoring out a negative by distributing that negative. Hey, and what did we do last time? This, since y squared plus 6y plus 9, that's y squared, that's 3 squared. What do we check? 2 times y times 3, that is 6y. Yep. So what is this? Y and 3 in the square, plus there, so plus there. This is actually x squared minus y plus 3 squared. And there was a lot to do to get it into that form, but we got it there, just using all these things that we've been learning over the last few lectures. We actually haven't done any factoring yet. We've just been rewriting. But the factoring basically takes care of itself now because we have a difference of squares. That's two things. There we go. 1 plus, 1 minus. The first of those things is x. Be super duper careful. The second thing is more than one term, the y plus 3. So we're not going to have a problem there. But we're subtracting the y plus 3. We're subtracting the entire blue thing. That y plus 3 needs to be in parentheses itself. So that when we simplify, nothing changes in the first one, x plus y plus 3. But in the second one, we distribute that negative. And we have x minus y minus 3. This would be the final answer. X plus y plus 3 times x minus y minus 3. Oh, okay. Let me do one more of these. One that works out the same way. Maybe it's a little easier. If we had x squared plus 10x plus 25 minus y squared, these three terms are what we would recognize as a square. And it's actually x plus 5 squared. And then this is minus y squared. We don't really run into the same issues that we did. Two things, 1 plus 1 minus. I left more room in the front since the first one's bigger. The first one's x plus 5. The second one is just y. Since the second one wasn't the one that had more than one term, that was a lot easier to get done. X plus 5 plus y times x plus 5 minus y. Almost done. Thank you for staying with me. The last two formulas we're going to talk about are what I call the SOAP formulas, not because they come from General Hospital or Hydra. Now, that would be blue soap anyway. I call them the SOAP formulas because it helps me remember the pluses and the minuses. SOAP in this case stands for same, opposite, always plus. What does that even mean? Well, right now, same, opposite, always plus. Say it. Right. Same, opposite, always plus. We use these formulas for sum of cubes and for difference of cubes. A sum of cubes would be a cubed plus b cubed, a sum of cubes. A difference of cubes, a cubed minus b cubed. Both of these are a binomial times a trinomial. A binomial times a trinomial. 2 terms, 3 terms. And that means that there's 1, 2, 3 signs. 1, 2, 3 signs. These signs are going to be the same as what we started with, the opposite of what we started with, and then always plus. So on the plus one, same, opposite, always plus. On the minus one, same, opposite, always plus. And then what gets filled in, the two things being cubed in order are A and B. So the first and the second, the first squared, multiply them together, the second squared. The first and the second, the first squared, multiply them together, the second squared. And that's how it works. So I'll give you a second to finish copying these down while I prepare our examples, our final examples. All the stuff we covered today, and we still might get done a little bit early. Okay. Let's take a look at 8x cubed minus 27. This is a difference of cubes. We can write it as cube minus cube. 8x cubed is what we get when we cube 2x. 27 is what we get when we cube 3. So these are our two things. The SOAP formula, a 2-term thing, a 3-term thing, binomial, trinomial. Our initial is a minus. Same, opposite, always plus. The two things are 2x and 3. Square the first, 4x squared. That's what we get when we square 2x. Multiply them together, 6x. That's 3 times 2x. Square the second, 9. That's what we get when we cube 3. That's the answer. Thank you. Next. $125 t cubed plus 64 z to the 6th. This may be a sum of cubes. 5t cubed gives us 125 t cubed. 4 z squared is what we cubed to get 64z cubed, or c to the 6th. 4 cubed is 64. Z squared cubed, multiply those together, gives us the z to the 6th. We're starting with a plus. 2 terms, 3 terms, same, opposite, always plus. The two things are 5t and 4z squared. Square the first, 25t squared. That's what we get when we square 5t. Multiply them together. 5t times 4z squared is 20tz squared. Finally, square the second. When we square 4z squared, we get 16z to the fourth. That's that. Finally, I want to do x to the sixth minus y to the sixth. This is a difference of squares. X cubed and y cubed are the two things being squared. So, conjugates, 1 plus 1 minus, x cubed and y cubed. X cubed and y cubed. This is a sum of cubes. Binomial, trinomial, same, opposite, always plus. X and y, x squared, xy, y squared. So that is a sum of cubes. We factor accordingly. This is a difference of cubes. We factor accordingly. Binomial, trinomial. It's a minus, same, opposite, always plus. X and y, x squared, xy, y squared. That had both of our special formulas we've learned in the same problem. That's it.